Good morning, everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, in our subject, Circuit Analysis and Devices, we are going to discuss about the PN junction diode. So, come, let's get into the topic. So, PN junction diode, that is semiconductor materials or whose conductivity lies between conductors and insulators. Semiconductors are classified as intrinsic semiconductors and extrinsic semiconductor. Extrinsic semiconductors are further classified as N-type and P-type semiconductors. The PN junction is formed between the P-type and the N-type semiconductors. In this session, let us know more about the PN junction. So the definition for PN junction. So the PN junction is an interface or a boundary between two semiconductor material types, namely the P-type and the N-type inside a semiconductor. In a semiconductor, the PN junction is created by the method of doping. The P side of or the positive side of the semiconductor has the excess of holes, and the N side or the negative side has excess of the electrons. So this is the symbol of PN junction diode. So where it's an anode, this is cathode, P-type silicon, this is N-type silicon, and this is the corresponding symbol is given over here. And formation of PN junction. As we know, if you use different semiconductor materials to make a PN junction, there will be a grain boundary that would inhibit the movement of electrons from one side to another by scattering the electrons and holes, and thus we use the process of doping. We will understand the process of doping with the help of this example. Let us consider a thin P silicon semiconductor sheet. If we add a small amount of pentavalent impurity to this, part of P-type Si silicon will get uh, converted to a N-type silicon. This sheet will now contain both P-type and the. So the N region under the junction between these two regions, the process that follows after forming a PN junction are two types: diffusion and drift. There is a difference in the concentration of holes and the electrons on the two sides of the junction. The holes from the P side diffuse to the N side, and the electrons from the N side diffuse to the P side. This gives rise to diffusion current across the junction. So this is the unbiased PN junction diode because there is no external supply to this PN junction diode. So it is called unbiasing PN junction diode. So where one side is P type and another one side is a N type material. In between we have a depletion region. So also when an electron diffuses from N side to P side, an ionized donor is left behind on the N side, which is immobile. As the process goes on, a layer of positive charge is developed on the N side of the junction. Similarly, when a hole goes from the P side to the N side, an ionized acceptor is left behind on the P side, resulting in the formation of the layer of negative charge in the P side of the junction. This region of the positive charge and negative charge on either side of the junction is termed as the depletion region. So biasing condition for the PN junction diode, there are two operating regions in the PN junction diode, P-type, N-type. So there are three biasing. One is a zero biasing or unbiasing, and another one is a forward biasing and reverse biasing. Zero biasing, which is nothing but of when there is no external voltage applied to the PN junction diode, that is called a zero biasing or unbiased condition. So where the forward and the reverse biasing quite different from the your zero biasing. So the forward biasing, the P-type P channel will be connected to positive, and the N channel will be connected to the negative side. So this makes the forward biasing condition. Where in the forward biasing condition, before zero point 0.7, that means since we are using the silicon as a material, so the zero point 0.7 is the threshold value for the silicon. So before zero point 0.7 voltage, there is no current flowing through the diode. If once the external supply reaches the zero point 0.7 or greater than of zero point 0.7, the current conduction will take place in the diode. So this is called a forward biasing operation. And a reverse bias just opposite polarity what we have done for the forward biasing condition. Here the positive will be given to N type and the negative will be given to P type. So where here there is no when we are increasing the voltage, there won't be any conduction in the PN junction diode, but at a certain condition, the breakdown voltage, after the breakdown voltage, there will be some heavy current flowing through the diode. After that breakdown, we cannot use the diode as diode. That will be permanently breakdown. So there are two kinds of breakdowns available. One is avalanche breakdown and Zener breakdown. So this is the VI characteristics of the PN junction diode, where the forward bias will have a forward voltage and reverse bias we have a breakdown voltage is there, and there we see that there is a very minimal current will be flowing through the reverse region, that is called as a reverse current leakage. The application of the PN junction diode is it used in a photodiode, and it can be used as a solar cell, and it is used in a LED lighting application and rectifier application. So these are all the applications of the PN junction diode. Thank you.